All right, so sometimes instead of given points, we're given a graph of an exponential function, and they want the equation of it. Well, how are we going to do that? Well, first we have to identify 2 points on the graph. And ideally, we're going to choose the y-intercept as one of the 2 points whenever possible, because that's just going to make it easier, because that will give us what? That'll give us our a value. And so if that's the case, that's going to give us 0 comma a. And so we'll have a. And then we're going to try to choose points that are as far apart as possible to reduce round-off error as well. So, if we have our point here, at 0, then we'll want to get something as far away as possible that we still can tell pretty much is going to be on, uh, uh, whole numbers is ideal, I think, as far as that goes. And so we'll look at something as far away as possible. Now, if one of the data points is the y-intercept, the 0 comma a, then a is our initial value. We don't have to do too much. And then using that a, we substitute that into here, and then we plug in our x and y, and we solve for b. Okay. And so then after that, we can plug in, and we'll have our f of x equals a times b to the x, and we have our function. But if neither of the data points have the form 0 comma a, then we're going to have to do like we did on another problem, where we plug in both points into the y equals a b to the x, and then we have to simplify and solve for b, and then solve for a and work our way down, and then we can simplify into our f of x equals a b to the x. Okay, so here's an example. Now, guess what? They give us it's a square root of 2. Okay, so that's going to be our a. And so with that one, we know a equals the square root of 2. And what we're supposed to do is find the exponential, but we were talking about that, so I didn't even read the directions. And so with that, then we have to find something far away as possible. So we could choose that one or that one or that one. It really, I don't know if any of them hit better than any others. Um, maybe, maybe we can choose this one. And let's say, it looks like it maybe goes through the point 3, 4. And so let's do that. And when you have wide lines, maybe 2, 3 would be a better one, but it looks like it's below here. That one looks like it's above. And we're just approximating, because we can't really get the nice simple, hey, it's a straight line and it's going exactly through that point. We get this kind of heavy line and it's above it a little bit, but we're going to go with 3, 4. Okay. All right, so what do we have to do? Well, we plug in our x and y in our a, and we try to solve for b. So y is equal to 4 equals a, which is the square root of 2, times b to the x, which is 3. Okay. Well, I need to solve for b, so I'm going to take and divide by the square root of 2. And so now I have b cubed equals 4 over the square root of 2. How do I get rid of a cube? Well, I take it to the 1/3 power, or I take the cube root of it, in other words. So then b is equal to, well, now I have to actually plug this into my calculator and figure out what that is. Well, if I take 4 divided by the square root of 2, and then get out of that, and then parenthesis, and raise that to the 1 divided by 3. Now, this shows up here, it's always like that, as stays in there, it doesn't go down, so we're okay there. That gives us this number here. Now, if you've been in math for a while, if you see something 1.4142, that starts to make you clue in that that's probably the square root of 2. So if I square that, I get 2. So that is the square root of 2. So coming back over here, that gives me b is the square root of 2. Well, now I've got my a and b, so I can write my function f of x equals square root of 2 times square root of 2 to the x power. Okay, and that would be my function. Now, are you going to get something different if you use one of these different points here and you're estimating? Yeah, you're going to get a little bit slightly different. But again, we're going to get something as close as possible with what we can guess as far as that point is. Now, nice thing we can do is we can use our calculators. And with our calculator, with 2 points, these aren't such nice points here, if you notice, we can use functions in our calculator to actually solve this for us. And so I can read these out, but it's going to be probably easier just to see when we actually type in our calculator. So we're going to press stat. We're going to clear any existing entries in columns L1 and L2. In L1, we're going to put the x coordinates, so we'll put 3, then 6. L2 will enter the y coordinates, so 75.98, 481.07. Then we'll hit stat again, and then we'll cursor right to the calc. We're going to do a calc. And then we scroll down to the exponential regression, press enter. And then we want to make sure we have everything proper. We want to make sure it's with L1, L2 for our X and Y's. Hit enter multiple times to get down, and then the screen will display our A and B, and it's going to say this is the form. Okay, so let's do this. We'll go over here to our calculator. Let's clear all that out. So now we're going to go to stat. We're going to edit. Now, if we have stuff in here, what we're going to do is we're going to go arrow up. We're going to say clear, then arrow down, and it gets rid of all of them. So it makes it a lot easier to get rid of everything all at once. Now, our points, what were they? Well, they were 3 and 6 for the x's, and y was 75.98, and then the second one was 481.07. All right, so now we have our input for x's and y's. Now we hit stat again, arrow over to calc. Now we want the exponential, so I'm going to arrow down because I know it's number 0 here. And so if we go up here and we see 0 is the exponential, we can type 0, and it takes us straight to exponential. Now again, we want to make sure x is L1, y is L2, and then we just kind of arrow down, and now we calculate. And this is our A, this is our B, and it says it's a perfect one because we only had 2 points, so we better get a perfect fit for that. So now what we do is we go back over here and we can write it down. So we're going to have some f of x equals our a. They said, well, maybe let's not put equals. Let's put approximately, because it was 12.000 something, and so I'm going to say it's approximately equal to, and I'm going to round it to 12. And then our other one, it had 1.84 blah blah blah, and I'm going to round it to 1.85, and then that's to the x. Now a lot of problems will tell you round it to this number of decimal places. So maybe we would have put 12.00 times 1.85 to the x. Maybe they said round it to 2 decimal places for both of them, and maybe that's what we would do here. If it said to 3, then we'd go to 3 decimal places, and so on. Okay, but that's a nice feature of our calculator. Now, of course, does that mean we have to always, where was the one in the back here? Do we always have to do it that way? No, we can still do it this way. And I might say, okay, here's 2 points. Show me all the work to get to there. Otherwise, I might say, okay, well, here's 2 points. Give me an exponential equation, and you can use your calculator, and you go boom, and you got the answer right away. So pay attention to the directions on for as far as what you can do. If it says use your calculator, go ahead and use your calculator. All right, compound interest. Well, that's interest earned on the original value as well as the interest accumulated. Okay. Now, some things we need to know. APR, well, that's also known as our nominal rate of interest. And the yearly interest rate is earned by an investment account. Now, nominal means it occurs a number of times a year. So maybe we have some examples here. Maybe it's twice a year. So that's semi-annual. Maybe it's 4 times a year. That's called quarterly. Maybe it's 12 times a year. That would be monthly. It's a big N. And, we could do weekly. So that would be 52. There's all kinds of different ones we can do. Daily would be 365. So all depends on what they ask for, okay? And this is the formula we'll use for compounding interest. It's going to be our future value or the account value after a certain amount of time. It's going to be the principal, P, times 1 plus our rate. Now note, the rate has to be expressed as a decimal. So if they give you it's 6%, well, you're going to have to convert that to 0.06 to put it into this equation. N is going to be the number of times per year compounded. So, depending on which they might say it's quarterly, and you have to know that that's 4. Then that's 4 up here as well, then, if the N is 4. And then times T. So T is measured in years. And so that's why we have to put these into this format so it bases it on a year. Okay. But that's going to be our equation for compound interest. And what they can do is they can ask for any of these values, and being good algebras people, we know how to solve for anything in this, and we can just do that. Now, majority of the time they're going to ask for a of some number, but sometimes they might ask what is the principal or what is the time. And so you have to be able to solve for any of those. All right, so what I'm going to do is I'm going to do two of examples. I'm going to do one where we have to find our A and one where we actually have to find our P. How much did we invest? So this is again my formula up here, P times 1 plus R over N to the NT. And what do we have for this one? Well, it says an initial investment of $100,000. Well, initial investment, that's my P at 12%, well, that's my R, but again, remember, we have to put that into decimal form, so that's going to be 0.12, is compounded weekly, so that is going to be my N is 52 weeks in a year. What will the investment be worth in 30 years? Well, that's my T. So just reading the problem, I was able to find my P, my R, my N, and my T. And now I just plug it all in and I get my value. So A of 30 equals $100,000 times 1 plus R 0.12 over N 52 raised to the 52 times 30. Okay. Now I plug that into my calculator. So I clear that out. So I'm going to have 100,000 times 1 plus 0.12 divided by 52 parenthesis raised to the power, and then it was 52 times 30. Okay, now I hit enter, and that's going to be my value. Now when we're working with dollar or money values, we always round to two decimal places, so that would be 0.88 there on the end. So that's going to give me the value 3644675.88. And again, to that penny. Okay. All right, so that's how you do that one. Well, the next one, let's see what it says. It says a 529 plan. It's a savings plan for college that allows relatives to invest money to pay for a child's future college tuition tax-free. Now, Lily wants to set up a 529 account for her new granddaughter and wants the account to grow to $40,000. So that's what we're going to get to eventually. So that's going to be our A value over 18 years. So that's really A of 18. This is our T. Now, she believes the account will earn 6% interest compounded quarterly. Well, 6%, that's going to be our rate, and that's 0.06. Compounded quarterly, well, that means N is equal to 4. So now to the nearest dollar, how much will she need to invest in the account now? Now, when we do this to the nearest dollar, usually that's not how it's going to be. Usually it's going to be we have to go up a dollar no matter what. If we said we had to invest 129.01, well, we're going to have to round that to 130 if you do it business in a business manner, because you always want to have more than what you have. If you rounded this down to 129, we're not going to reach 40,000. We're going to reach $39,995 or something. I don't know exactly what it'd be, but we would never reach it. So we'd always have to round up, and then we for sure get our 40,000, and it actually might go over, which is fine. Okay. So let's plug in everything we need. Well, we said A was going to be $40,000, and that was equal to, now we said our P is what we're looking for, so P times, then we have 1 plus, and our rate was 0.06 over, and our quarterly was 4, and that's raised to the 4 times T, which is 18. So now we want to solve for P. Well, how do we do that? Well, we just divide by this whole thing here. 1 plus 0.06 divided by 4 to the 4 times 18 divided on that side as well. And so then that gives P is equal to, well, now we have to plug all that into our calculator. And again, I'll show you how it should look, hopefully. So 40,000 divided by parenthesis, and we had 1 plus 0.06 divided by 4, and then that was raised to the 4 times 18. And this whole thing is divided by this whole thing. And so that says we should invest 13,693.19999. Now, again, because it said rounding to the nearest dollar, it didn't say to do it the proper manner with the counting and banking, that would give us 13693. Now again, if it didn't say the nearest dollar, we would actually round it up to 13694. And then with that number, we would for sure get to the 40,000. If we plug this number back in, we're not going to get up to the 40,000. So that's going to be kind of our key difference here. So let's go back and kind of show you that. So if we go back here and go to the very beginning, and we put the 13693 and then times this, what do we get? 39,999.41596. And that does not equal 40,000. So that's why I say if we put in that, with the 4 there, we will reach 40,000. And again, we're going to be over, but we reached our goal of 40,000. So that's kind of the difference when it says round to the nearest dollar, we might not actually get to the value we want. All right, let's stop there and we'll come back for more.